Okay, this is Spearman's rank correlation. So correlation has to do with, in general, sometimes if you're looking in this book, it's sometimes known as Pearson correlation, but we've been talking about correlation coefficient for years. Well, the difference here is we are now talking about the correlation in rank, not the correlation in actual value. So when we've done correlation, we've done X value versus Y value. What we're doing to now do is rank order instead of rank order of X value versus rank order of Y value and finding correlation that way, instead of simply finding the actual correlation between the numbers. So the big picture here, we've got runners on a track. Okay, and in these runners on a track, yes, we might care a little bit about their times. They probably care a little bit about their times, but they care more about their rank place value. It's more important to get first than to get a best time. Yes, getting a world record time is great, but I'd rather win the Olympics than get the break the world record time and get second. So rank order sometimes matters. That's kind of this rank idea of first, second, third, fourth, fifth is what we've got in this race. Okay. And statistics is used to verify results and test for bias in numerous applications. Spearman's rank correlation is one tool that can be used to test consistency in subjectively rated assessments. Okay. So they're using it to test consistency, especially in things that are subjective, because it's easy to rank things in order subjectively. It's sometimes harder to rank a numerical value to them. So, can these situations besides the employee evaluations described above where ratings are used? So, sometimes ratings you can rank employees based on evaluations and where they rank in an order to justify a validity. Now, there's something, this has sometimes been used for grading. Sometimes we don't want to use it for grading because not all classes are the same. We can't just rank you in order and expect you to be the same as the previous one. So they try to rank sometimes to standards. So this isn't always valid. Okay. Researchers notice trends in data. This is the concept box. Various statistical texts are used to determine the validity of the hypothesis they make. Again, this is one available one. Okay, it's not the end all be all. It's really important to note that with all statistical tests. So, understanding the Spearman rank correlation coefficient, 4.10.1. And maybe it'll let me advance to the next. And it's stuck. Okay. So, choosing the test. Oh, there it went. So, a couple of things. We have nominal data, which includes data that are separated into categories but do not have any particular order, or ordinal data, which has a first, second, third, and a definite rank order. So these are two very important types of data. Nominal is just generally often categorical, but doesn't have any particular order, or ordinal, which has a specific order. If you're talking about just generally numeric data, you can assign it an order. Usually it's ascending or descending order. Okay? But those are your two very important types of data. Okay? You generally need ordinal data for Spearman's rank correlation. Okay? There's also interval data, which has data that is indicate a consistent distance between consecutive values, or sometimes not. Or there's ratio data, which is proportionality. Okay, interval data sometimes can be thought of like a histogram. You can think of how many data points in this interval sometimes. So Nominal, male, female, left-handed, right-handed, ambidextrous, cars, trucks, motorcycles, vans. Nominal data can be done, and you can use chi-squared tests sometimes on them, or a lot of times you'll do proportions within each group or how many in each group. Okay. You can sometimes have two groups and t-tests could be run, but chi-squared often is done for multiple categories and how many in each category. Ordinal is oftentimes done with rank correlation. First, second, third, small, medium, large, disagree, ambivalent, agree. Anything where you've got categories and there's a particular order to the categories. Or you just rank the orders. There's interval data or just general numerical data. Interval can be like chunks, like a histogram, or it can simply be numerical data. And there's ratio data, measurements of length, distance, area, time, speed, or acceleration. Ratio speed is often meters per second. That's ratio data. Okay. And what they're talking about here, interval, they're talking about year versus temperature versus ratio, they're talking about length versus distance. So that could be a ratio, or length versus area, or length versus distance versus time. That's speed. Okay. These types of where there is actually a relationship between those two. Again, those are just standard correlation. Sometimes this book calls them Pearson's correlation. That's just R. That's you've been calculating since integrated one. Your calculator calculates that for you. It's a big pain to do without it. Okay, so Spearman's rank. Be aware, if you are collecting data to analyze, it is best to gather it in the most precise form. You can always convert it into a more general form as needed. If you initially planned a chi-square test but decided to do a Pearson's correlation coefficient instead, it will be impossible if all your data was nominal. So collect it as precise as possible. Don't collect it in rank order, So if you're collecting data on a race, collect the actual times. Yes, then put them into rank order and you can do the rank test. But then you at least have the times if you decide you need to do something else. The four data types, nominal, ordinal, interval, and ratio, provide one example of how language is used within an area of knowledge, the mathematics area of knowledge, to indicate different meanings. In order for a data set to be useful for a particular analysis, it must contain the proper type of data. Okay? And knowing these and what they mean, and it's not just an English definition. Okay? Categorizing data like this enables us to communicate requirements for mathematical tests clearly without having to explain the concept each time. That's really important that we know and understand what these terms mean so you don't have to re-explain it every time you need to use it. So language is a very important part of mathematics, as is notation. It would be very ugly if we didn't have those. So the purpose of Spearman's rank correlation, it's used to find the strength of correlation between two sets of ordinal data that show a monotonic trend. Monotonic means it's going one direction. Okay? It's either going up as I go across that's a really bad y-axis. Up as I go across the graph, or it's going down. There's all kinds of data that looks like this. This is not monotonic. Okay, so it has to be ordinal and it has to be monotonic. If it doesn't meet those requirements, you can't use it. Other examples might include finding correlations between level of education reached and annual salary, or between someone's position in a company and their year's experience. Variables like level of education and position in a company may not seem like ordinal data, but remember that the order can be implied by increased position or some other measure of quality. Okay, so you do have to order everybody's positions then. Okay, there can be ties in the order, but you do have to order positions to use this. So things can be put with orders that might not necessarily seem that way. Sports tend to use this a lot. Calculating the Spearman's rank correlation. So Spearman's rank correlation uses the subscript S. Generally, correlation uses R. R sub S is Spearman's rank correlation. Okay. And here we have an example. We have runners in a race. We have their rank at 2 kilometers and their rank at the end of the race, or essentially their place. So runner A was in first at 2 kilometers and third later at the end. B was second for both. C was third after 2 kilometers but won the race. D was fourth but finished fifth. E was fifth but finished second. F was sixth but finished fourth. And we can see that there's some relationship, and then they made a graph here. Okay. There was only one racer that finished the same position. So here is the formula. We're going to talk about what D means in a second and what N means, but this is the formula. Write it down in your notes. R sub S equals 1 minus 6 times the sum of the distances squared divided by N times N squared minus 1. N stands for number of data points. D is the difference between ranks of the independent and dependent variable. In this case, independent was placed at 2 miles, dependent was placed at the end. So let's actually learn how to calculate this. So calculate for the runners above. So we get 1 to 3. That's 1 minus 3 is -2. That gets us a D of -2. We're adding the D squared, so that becomes 4. So the order that I subtract doesn't really matter. 2 minus 2 is 0. 3 minus 1 is 2. Again, D squared is 4. And we can add all of these values up. And this gives me all my D's. So notice here they give you the sum of the D squareds is 18. 4 plus 4 plus 1 plus 4 plus 4 plus 1. So using my formula, I'll write it out. This is sum of the D squareds. My formula was 1 minus, I guess it's written right here, 6 times 18 over, there's 7 in my data set, 7 squared minus 1. So N was 7 for both of these. Sum of the D squareds is 18. They literally just added all of those numbers, my D squared column. When I get this, I get, and I would just use the calculator. I jumped straight to this 0.679. I'm not going to work out the fraction. I don't think it matters. 0.679. Okay, that's a correlation. Spearman's rank correlation works very similarly to Pearson's correlation. Close to 1 is strong correlation. Close to 0, poor. I don't think you can get a negative, though, out of this. Okay. I do not think this formula can possibly generate a negative. Because some of your D squareds can't be negative, so you can't get, yeah, it's just not going to work out that way. I don't believe. So that's it in calculating it. It really wasn't, it's a little bit tedious. You got to calculate all those distance squareds between the intervals, but it really wasn't all that hard. So You will not be required to remember or use the formula to find R sub S. You will be showed how to do it with technology, but you probably should work the formula. The keys, though, the data has to be ordinal and monotonic. Each element of the set occurs only once. In other words, there are no ties. Okay, so there's a way to deal with ties. We'll talk about that in a second. But so this is it's generally correlation, but it's correlation based on rank instead of correlation based on interval value or ratio value. Okay, so using technology to do this. So Spearman's rank correlation is helpful. However, if you have ties, so here's our sets. And I'm going to rank their order. Okay, so they can't and give it a rank. I've got 3, 5, 6, 6, 8, 11. So this is first. This is second. These two here are tied for third. That means they're split between third and fourth. So they each get a 3.5, a 5, and a 6. Okay? Set B, that's first. These three here are tied for second, third, fourth. So we average second, third, fourth, and we get third. So second, third, fourth, this is fifth, sixth, is 9 is sixth. So ultimately, my data goes essentially as a table of 1, 2, 3.5, 3.5, 5, 6, and goes 3, 3, 1, 3, 6, 5. And it essentially what I'm going to do is calculate a correlation based on that. Okay? And I'm going to do correlation just like I did regular correlation. I'm going to delete this stuff. Keep that table off to the side. So using the rankings from the table above, I'm recording. So I'm recording. Can you come back in a second? Okay. So using the rankings from the table above to find Spearman's rank correlation. So essentially, I'm going to find the linear regression using my calculator, just like I always do. I'm going to do this on the Inspire, but those of you with the TI-84, it's just standard regression. So I'm going to start a new document. Actually, I should go here. New document. No, I don't need to save. I don't know what I have here. But I'll add a page. I'm going to add a list in spreadsheets. I'm going to name it AA because it's simple. I just enter my ordered list. I do 2 letters because then it can't screw up the name of the column versus the name of the. So there's my ordered list. If I want this, I'm going to add a calculator, press menu, statistics, stat calculations. I'm just going to let it do either linear regression. It doesn't matter. I chose easy letters. My Spearman's rank correlation here is R, 0.585. Not amazing, not terrible. We could see, I mean, if you just look at this data, you're like, that's kind of correlated, I guess, maybe. The further ones are further up, and these ones are at the bottom. So there's some level of correlation, but it's not that good. So did the linear regression on the calculator mean anything? The answer is, I suppose this would be the regression line predicting the ranks, but really what we're interested in is simply this R value for Spearman, and this is Spearman's rank correlation. We can then interpret that to mean it's somewhat correlated, but not particularly strong. Okay. So we've got this is where it comes in really interesting. The table shows the scores given for two judges for skating skills for 20 finalists in the ice dance free dance competition in the 2021 World Figure Skating Championships. And there should be a reasonable amount of correlation between scores. You don't expect judges to score them the same, but who they judge being the best should be reasonably correlated. Okay? Whoever's the best should generally, there's some subjectivity to this, but there shouldn't be so much subjectivity that there's no correlation between who judge one and judge two think is the best. There should be a reasonable amount of correlation. So to find the Spearman's rank correlation for the results, we need to put them in order. This one is clearly one. These two are tied for second, so that's going to be 2.5, 2.5. Got a 9.25 here. That's going to be 4. I got these three are 9s. That's 5, 6, 7. The average is 6. So this is I'm just putting them in order. This is going to be 1. These two are 2.5. I think they ordered them based on overall, on average score. Nope, definitely not. I don't know how they put these in, what order they put these in, but this is 4 and 5, so 4.5 for each of those. So 6, 7, 8, so 7. And I'm not going to worry about, oops, I'm not going to worry about finishing the list. They did that for me in the example. So if I go down here, I can see they've ranked them all for me. Same approach I used. So now, if I want Spearman's rank correlation, I can put them into the calculator. I'm putting in, if I'm looking at column 1, L1, L2, and doing a correlation, or maybe on the Inspire AA, BB, I'm doing the same correlation that I've always done with the linear regression. I trust that you guys can do that. So here's what it gives me. 0.933. That's pretty solid correlation. There's a relatively good, strong correlation between how the judges ranked who was best. They didn't line up perfectly. You know, this person's got a 7.75 from that judge, and this person's got an 8. This person's got a 7, this has a 7.25. Again, they're not scoring them exactly the same, but their ranking order is similar. This one ranked tied for 20th, this one ranked 20th, or tied for 19th. This one ranked 17th, this one ranked 18th. Okay, so I see a lot of correlation between them. And Spearman's rank correlation is simply a way to assess how closely do these ranks line up. Okay? So we're not going to actually do this, but it's worth thinking about. People often have very different opinions about new movies. Professional critics give their opinions and then public assess the movie in the form of purchasing tickets, posting online reviews. Look up critic reviews and ticket sales for at least five different recent movies and use Spearman's rank correlation. You'd find they should be somewhat similar. You could do this if you want, or you don't have to. But that's just it's an interesting way to, if you rank things in an order, see how does you can see how critic reviews line up with public opinion reviews. Okay. And go, is there a good correlation here or not? But again, you're ranking the order, not the number, not the review number. So out of five, I don't care. I want them ordered versus this one was highest rated of these five, or etc. That is a really key thing for Spearman's rank correlation.